Okay. Hello, students. We are live. If there is anybody in the chat section, please let me know if I'm properly audible. Just give me a quick thumbs up in the chat section so that I'll know everything is fine with my stream. It's fine with. Just give me a quick thumbs up, guys, in chat section. Okay, so everything is fine with my stream. Let's just wait for 1 minute so that more students will gather and then we'll start the session. Okay, so guys, in today's session as well, we are going to discuss machine learning questions for GATE exam, right? I had already taken 2 sessions. If you haven't gone through that, you can go through previous 2 sessions on our Geeks for Geeks GATE channel, right? And there you can see that we have covered so many algorithms and the questions based on that. And also, if you have problem in any algorithms to understand, then you can go through previous videos as well, in which we have taught in detail the algorithms like decision tree, knn, everything we have discussed there, right? But these sessions which we are going right now, we are only discussing questions, right? If you face any problem, anything, you can just let me know in the chat section. Okay, so shall we start questions? Just let me know students have joined or not. So guys, if you remember in the last class, we were discussing naive Bayes algorithm, and I told you that why we call this Bayes algorithm as naive Bayes algorithm, because it has some assumptions that are innocent assumptions, which generally do not happen in real life, right? In real life data set. So that's why we have this naive Bayes algorithm. We have discussed that. Now let's discuss some questions based on naive Bayes algorithm, and then we'll move to discuss questions on decision trees. Okay, so let's start with the question. This is the first question. It says that use naive Bayes algorithm to determine whether a red domestic SUV car is stolen or not using the following data. So guys, you can see that I have given a data set, and now they have given another query, right? This is a data set given to me in which we have given 10 examples, and they have given a query that this red domestic SUV car is a stolen car or not. I have to tell them, right? So using naive Bayes, I have to tell. Can anybody tell me? Does anybody have any idea? How would you find out? So let's suppose this color is my X1 feature, type is my X2 feature, and origin is my X3 feature. What they are asking? They are asking that if X1 is red, X2 is SUV, and X3 is origin, then I have to find out that the car is whether stolen or not, right? So for that, what would I do? I'll find out probability of classes. Let's say I have C1 is equals to yes and C2 is equals to no, right? So what would be probability of C1? If you would see probability of C1, out of 5 examples, 1 2 out of 10 examples, you have 1 2 3 5 4 5 5 yes and 5 no. So 1 by 2 is a probability of class C1. Probability of C2 is again 1 by 2, right? So these two are the probabilities. Now what would I do? I'll find out the probability. What we do in naive Bayes, I'll find out the probability, that what is the probability of the class C1 if I have given the example X. That means I just want to find out what is the probability of C1 given example X, where this X is, X1, X2 and X3, right? And X1, X2, X3 are, or you can say that either instead of X1, X2, X3, I can take that X1 is equals to red, X2 is equals to SUV, and X3 is equals to domestic. Right? I have this. Now I have to find out probability of a class given this example X. right? Now you can see that what naive Bayes does. Naive Bayes find out that let's suppose we have given this example we have considered as X. So given this query, I'll find out probability of class C1, I'll find out probability of class C2, which of the probability is major, right, is maximum, I'll assign that class to this particular example, right? That I'm going to do in naive Bayes. If this thing is clear, then we can move to the calculation. Just let me know, guys, if there is any confusion till now. So how do I find out the probability? Because we have the theorem name is naive Bayes. We are going to use Bayes algorithm. So guys, it would be probability x1 given c1 into probability x2 given c2 and into probability x3 given c3 and probability x1 given c1, x2 given c1 and x3 given c1 into probability of c1. Right, that's how I can find out probability c1 given x. Guys, if you want to know that how we find out these probability c1 given x in detail, that how we got this formula, I have already discussed in the in previous lectures where we have discussed naive Bayes algorithm. You can go there if you want to know this algorithm in detail, but right now I'm solving question. Now probability x1 c1, because we are talking about c1 class, so I'll consider this yes, this yes, this yes, because c1 I have taken as yes. These 5 examples I have considered yes. Now x1 is red. So out of these 5 examples, 1, 3, 5, 7 and 10. These 5 examples are given. So out of these 5 examples, see how many we have read? 1, 2, this is not red, this is not red, this is red. So probability would be, that means out of 5 examples, I have 3 red. So probability here would be 3 by 5. Right? Probability here would be 3 by 5. Now they're asking what is the probability x2 given c1. Obviously c1 classes these 5 examples and x2 is SUV. So let's see how many SUVs we have in these example. 1 is sports, 3rd is sports, 5th is sports, 7th is SUV, okay, and 10th is sports. So out of 5 examples I have 1 SUV. So probability would become 1 by 5. X3 given c1, x3 is given to me domestic. So you can see that this is domestic, this is domestic, this is imported, imported. So out of 5 examples we have 2 domestic, so 2 by 5 and probability of c1 is 1 by 2, right? So I get this probability. Now you can solve it. 2 and 2 get cancelled, so probability would become 3 upon 125. So that is a probability of a class c1 given the query x. Now I'll do the same thing. I'll find out probability c2 given x. So again same thing, probability x1 given c2 into probability x2 given c2 into probability x3 given c2 into probability of c2. I'll do that. Right? What is the probability of x1 given c2? Let's see. What is c2 here first? Let's decide that what are the examples of c2. This no, this no, this no, these two. So that means 2nd, 4th, 6th and 8th and 9th. These 5 are the examples of class C2, right? That means no. Now out of this, I'll check how many red I have. I have 1 red, yellow, this is yellow, this is yellow, this is yellow. So that means I have 2 red. So that means out of 5 examples, I have 2 red. X2 is SUV. Now let's check how many SUVs I have. This is sports, this is sports, this is SUV, this is SUV and this is also SUV. So probability would become 3 by 5. Now x3 is domestic, so I'll check for domestic. This is domestic, this is okay, this is domestic, this is imported, this is domestic. So out of 5 examples I have 3 domestic, so it would become 3 by 5 and probability of c2 is 1 by 2. Now if you would solve it would become 9 by 125. So you can see that probability of a class c2 is more than probability of a class c1 given the query x. So what would you assign this example x? So you would say that this x query is, you would assign class c2. That means no. That means the red domestic SUV car they have given the example is not stolen. Is not stolen. Okay, just let me know guys if there is any confusion in this. Anyone has any confusion? Guys, you can just let me know if there is any confusion in this question, because we are going to solve further more question, and then those question you have to just solve by yourself. Okay, let's move on to next question then. I'm assuming that you guys get this. So guys, this is again a different data set, and the test instant here is slow, rarely, no. So you can see that you have given swim feature, fly feature, crawl feature. Now they just want to know that what is a class of the particular species. If the species feature is that the species swims slow, it does is fly rarely, and it does not crawl, what would be the explanation? The last one, what is the last one explanation? What do you want to ask, Rahul? So basically, I have said that probability of class C2 is more, right? 9 by 125 is more. So I'll assign the example X as class C2, right? That what I have said. Okay, now let's go back to the question. So I just want to know that if a particular species swims slow, fly rarely, and it does not crawl, then what would be the class? Fish, animal, or bird? We have given three classes. Just let me know. So here I have three classes. So let's take C1 as fish, C2 as animal, and C3 as bird. Right? If you would find out probability of C1, what would be? We have given 12 examples, and out of this, how many fish I have? 1, 2, 3. I have 3 fish. So 3 by 12 is a probability, that means 1 by 4. Comma, probability of C2, that means probability of an animal. 3, 4, 5. I have given 5 animals out of 12 examples. Probability of C3, bird. 1, 2, 3, 4. 4 birds. 4 by 12. That would give me 1 by 3. Right? So these are the probability of the classes C1, C2, and C3. But the question arises that what is the probability X given C1? And what is X here? X is slow, rarely, and no. So I'll take X1 as slow, X2 as rarely, X3 as no. That is your X. Let me know, guys. This thing is clear. Now, can you tell me that what would be the probability X given C1? Sorry, probability C1 given X. C1 given X. What would you do? You would write down probability X1 given C1 into probability X2 given C1 into probability X3 given C1 into probability of C1. Right? Now, let's see class C1, fish. So we have this fish, this is fish, this is fish. I have 3 examples of fishes, and they're asking for slow. First feature is slow. So I have given 2 slow out of 3. So 1 by 3 is a probability. Next feature is rarely. So you can see here that this is no, this is no, this is no. So that means out of 3 examples of fishes, I do not have any example in which we have fly rarely, right? So that means the probability would become 0 by 3. Now X3 given C1, X3 is what? No. So this is no, this is no. Out of 3 examples, we have given 2 no. 2 by 3 into 1 by 4. So on solving, we'll get the probability 0. Right? We get the probability 0. Now what would I do? I'll write down probability C2 given X. So it would become X2 given C. Okay. I'll write down here probability X1 given C2 into probability X2 given C2 into probability X3 given C2 into probability of C2. Right? I can write down this. Now I can find out the probability. So let's see what are the examples I have to consider. I have to talk about now animal, right? So this is animal, this is animal, this is animal. These two are also animal. So I have to take slow. So this is slow, this is slow. Out of 5 examples, I have 2 slow. So probability would be 2 by 5. See guys, in this for class C1, I have only 3 examples, but for class C2, I have 5 examples. So probability would become 2 by 5, right? Now for the class, for the feature rarely. So you can see here that we have no, 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 and no, rarely. We have one example of rarely in animals. So probability would become 1 by 5. No, does not crawl. So this is no, this is no, this is no. So I, out of 5 examples, I have 3 examples which says no. So that means 3 by 5, and probability of C2 is 5 by 12. On solving, 3 4s are 12, 2 2s are 4. That means 50. 1 by 50 is a probability. Right? So this is a probability. Now, what would I do? I'll find out probability C3 given X. C3 given X. Probability C3 given X. Now for class C3, we have bird 5, 6, 11 and 12. We have 4 examples. If I'll talk about no, 1, 2, 3. I have 3 examples of no. Probability would become 3 by 4. 3 by 4. I am not writing the formula. You can write down by yourself. Now for rarely, I can see here that we do not have any rarely in examples of bird. So this would become 0 by 4. No matter whatever be the next probabilities, it would become 0. So now you can see that out of C1, C2 and C3, what would be the maximum probability here? Maximum probability is for C2. So that means this example X is assigned as C2 class, and C2 is what? Animal. So that means this example, this species example which is given to us, that swim slow, fly rarely, does not crawl, is an animal. Right? So just let me know guys if this thing is clear. Anyone guys have any confusion in this question? Just let me know. Okay, just give me a quick thumbs up in chat section if you guys understand this question. Just give me a quick thumbs up so that I'll know this is clear to you. Okay, let's move to next question. Okay, so the question here says that consider the following data set showing the result whether a person has passed or failed in the exam based on various factors. Suppose the factors are independent to each other, we have to classify new instant that we have given confidence equals to yes, study equals to yes, and C equals to no. So now I want to classify this example based on this data set using naive Bayes, because they have already said that factors are independent to each other. So that means I can use here a naive Bayes algorithm. Right? So let's do that. What we have to take? So I have to take x1 as yes, x1 as yes, x2 as yes, and x3 as no. And result, I have only 5 examples, right? And we have 2 classes here, fail and pass. So probability, let's take C1 as pass and C2 as fail, right? Let's find out probability of C1. What would be probability of C1? We have 3 examples of pass. So 3 by 5. Probability of C2, that means 2 by 5. So these 2 are the probabilities. Now what would be the next thing? I'll find out probability C1 given X. X is what? X1, X2, X3 given. So probability X1 given C1 into probability X2 given C1 into probability X3 given C1 into probability of C1. I'll write down this. Now let's solve with me guys this question. X1 given C1. Now if I talk about class C1, so we have this example, we have this example, these 2 examples. So they have said that yes for the first feature. So this is true, this is true. Out of 3 examples, we have 2 are 2. True, 2 by 3. Probability x2 given C1. X2 is given yes. So this is no, this is yes, this is yes. So out of 3 examples, we have given 2 yes. So 2 by 3. Probability x3 given C1. X3 is given to me no. So this is yes, this is no, this is yes. So that means we get one example 1 by 3, and this is what? 3 by 5. So on solving, we get the probability 2 2s are 4, 3 3s are 9, 5s are 45. So we get this probability. Right? Now once we get this probability, now I can find out probability C2 given X. That would become probability x1 given C2 into probability x2 given C2 into probability x3 given C2 into probability of C2. Right? Now let's talk about for the classes C2. That means this example and this example. These 2 examples I can take. So first they have said yes. So that means out of 2 probabilities, it would be 1 by 2. Then you have to take yes. So this is yes. So probability would become 1 by 2. Then you have to take no. So this is no. That would become 1 by 2. And probability of C2 is 1 by 2 again. Sorry, 2 by 5. 2 by 5. 2 and 2 get cancelled. 5 2s are 10. 10 2s are 20. So we get the probability 0.05. Right? This would be the probability 0.05. And if I'll divide this, 4 divided by 45.009. Right? We get this probability. 9 5s are 45, 9 4s are 36.08, something 0.08, 0.08. And you can see that the class C1 has more probability as class C2. So that means this example given to you, this new instance, this new query given to you is classified as class C1, right? Now let me know, guys, if there is any confusion at all in this question. Let me know if there is any confusion. Guys, if there is any confusion, you can just ask me in the chat section. I just want that it would be clear to everybody. Okay, let's move to next question. Okay, let's see next question. So next question, okay. So guys, we have again a question based on naive-Bayes algorithm, and it says that consider the following data set. A, B, C are the features and K is a class which are taking the value 1 and 0. Right? K is taking the value 1 and 0. Classify the test instance below into class 1 and 0 using a naive-Bayes classifier. So we have given the values of A, B, C, and now they are asking, given these values, what would be the class here? What would be the value of K? Now just try to solve this, guys, and let me know what would be the answer. Just try to solve this. Again, you have to do the same thing. Let's take C1 as 1, C1 as 1 and C2 as 0. And solve it and just let me know what would be the class of the given example. Guys, this question you have to try by yourself. I have solved 3 questions for you. You just let me know what would be the answer. So guys, what would be probability of C1? That would be 3 by 5. I have given 1, 2, 3, 4, 5, 6. 6 example. So it would be 3 by 6. And probability of C2 again 3 by 6. Right? So these are the probabilities of C1 and C2. Now what would be the next step? I'll find out probability C1 given X and X is given 0, 0, 1. X is 0, 0, 1. Right? So let's find out. It would become probability x1 given c1 into probability x2 given c1 into probability x3 given c1 into probability of c1. Right? So what would be this probability? Let's find out. So c1 we have given as 1. So that means this example, sorry, not this example. Okay, let's take, we have this example, this example, and this example, first, second and last one. So out of this I can see here that x1 I have to take 0. So out of these 3 I have only this 0, and here if I'll see in B how many zeros I have, this one is 0 and this one is 0, and this one I want 1. So this one is 1 and this one is 1 and this is 0. So now you can write down all the probabilities together. So this probability would become 1 by 3, this probability would become 2 by 3, and then 2 by 3, and then 3 by 6. That means 1 by 2. Can I write down this as 1 by 2? So 2 and 2 get cancelled. It would become 3 3s 9, 27. 2 by 27 is the probability. 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 2 by 27 is the probability Do you get it, guys? Now, what would I do? Similarly, I'll find out probability C2 given X. So it would become probability X2 given C1 into probability, sorry, probability X1 given C2 into probability X2 given C2 into probability X3 given C2 into probability of C2. So let's solve it for this one. So now I have three examples. These three examples. So let's see 0, 0, 1. So we have 1, 0 here, and I need 0 here. This is 0, and these two are 1. Right? Now if I'll write down the probability, this would become 1 by 3, 1 by 3, 2 by 3, and 1 by 2 is a given. So on solving, we'll get the probability 1 by 2, 1 by 27. So you can see that if I'll compare the probability C1 given X is 2 by 27, probability C2 given X is 1 by 27, which is large? C1 given X, right? So that means this is classified as C1. And what was C1? C1 is 1. So the given instance, the given query is classified as 1. Is it clear, guys? Just let me know if there is any confusion here. If not, let's move forward to next question. So this is the next question, guys, and this is little bit different. It says that find out the probability k is equals to 0 given a is equals to 1, b equals to 1. And this is different. Now they are particularly asking the probability, right? So using naive Bayes, you have to find out the probability. So what naive Bayes says? What Bayes algorithm says? Probability a given b is equals to probability b given a into probability of a upon probability of b. So I have to do the same thing here, right? I have to do the same thing. So how would I solve it? How would I solve it? I'll use naive Bayes algorithm. Probability a equals to 1, b equals to 1, given k is equals to 0. And I'll write down probability k is equals to 0 upon probability of a equals to 1 and b equals to 1. So this would be the probability. Right? This will be the formula for this probability. Now let's find out. So can I write down this as probability a is equals to 1 given k equals to 0? Because I know that the features are independent. Probability b equals to 1 given k is equals to 0 into probability k equals to 0 upon probability a equals to 1 into b equals to 1, comma b equals to 1. Right? So now let's solve it. When k is 0, in these three examples, what is the probability of a is getting 1? I am getting in two cases as 1. So that means probability would become 2 by 3. When k is 0, what is the probability of b being 1? So I am getting in two cases as 1. So 2 by 3. What is the probability of k equals to 0? Out of 6 cases, I have 3 zeros. Right? Out of 6 examples, I have 3 examples of 0. So this would become 3 by 6. Right? Now, the question is that you need to find out probability a equals to 1 and b equals to 1. So let's see where you are getting. So in this case, you are getting a equals to 1, b equals to 1. And in this case, you are getting a equals to 1, b equals to 1. That means at the same time, you want both a equals to 1 and b equals to 1. And you are getting only in 2 cases. So now you can write down that out of 6 examples, we are getting this 2 by 6. In 2 cases, so 2 by 6 is a probability. Now if you would solve it, it would become 2 3s are 6, 3 3s are cancelled, 2 3s are 6, 3s are cancelled. So probability would become 2 by 3. So here option B is correct. Just let me know, guys, if this thing is clear. Now you would say that, ma'am, in previous question, when we have found out the same kind of probability, what we have done? We have found out the probability C1 given X, and I have only written it as probability X1 given C1, X2 given C1, and X3 given C1 into probability of C1. I haven't written anything in denominator, because in these questions I just have to classify the instance, right? I just have to compare the probability. So that's why I have removed the denominator. So this probability is approximately equal, right? This probability, I'll say that it is like we have to just compare. So that's why this is approximation we have taken. not the exact probability. Exact probability you are going to find out using naive Bayes algorithm. That's why you have naive Bayes algorithm in your probability and statistics section. Now let me know if there is any confusion in this. Okay, if not, let's move to next question. Okay, so guys, this is another question, and this question is based on decision tree. But before starting decision tree, I just want to ask you that what is entropy and information gain? Does anybody have any idea about entropy and information gain? So basically, in decision tree, we'll take a particular feature and divide our whole data set into subsets, right? That what I do in decision tree, right? I'll get a tree with each feature I'm dividing. But the question is that which feature I have to take at the start, initially, right? How do I decide? That I decide based on entropy and information gain. So entropy tells you measure of impurity, measure of impurity. And the formula of entropy is equals to minus pi log to the base 2 pi. Pi is a probability of a particular class if we have n classes, right? That is your entropy. And if I'll talk about information gain, so using entropy we are going to find out information gain, and information gain basically tells us that which feature is going to give us maximum information. So that means higher the information gain, that means higher the importance of that particular feature. So I'll take that particular feature for my decision tree at the initial stage, that which feature has highest information gain, right? This thing is clear. So yeah, we are going to solve this. Now the question is that consider the data set as given below. We have given elevation, road type, speed limit, and based on that I got the speed, right? Now they are asking that elevation, road type, and speed limit are the feature, and speed is a target variable that we want to predict. Okay, that is about the data set. Now they are saying that find the entropy of the data set. So I need to find out the entropy for this data set. So if you would see in this particular data set, I have too slow and too fast. That means I have two classes here. So what would be the entropy? Entropy would be, I told you the formula is minus summation pi log to the base 2 pi. So obviously for slow we have probability 1 by 2. For fast we have probability 1 by 2. Because out of 4 examples we have too slow, too fast. Probability of slow 2 by 4. That is 1 by 2. Probability of fast, that is again 2 by 4. That is 1 by 2. So let's write down minus 1 by 2 log to the base 2 1 by 2 plus 1 by 2 log to the base 2 1 by 2. We get this entropy, right? And on solving we, it would become log to the base 2 1 by 2. Can I minus 1, and can I write down log to the base 2 2 to the power minus 1? Using log property, minus would become front, minus minus plus log to the base 2, and it would become 1. So we get the entropy here 1. So we can say here, when we have a binary classification, we have maximum entropy 1, because you can see that it has maximum impurity. Why? Because it is dividing it into two parts, two equal parts, too slow, too fast. So you can see that if somebody is dividing between 2 and 3, so I know that major part is here. If I do not have any information, I'll go there. But when I have 2 so I do not know whether to go here, whether to go here, right? So that's why entropy basically measure of impurity. And here is, we for binary classification we have maximum impurity as 1, right? So I can answer this question that entropy of the data set is 1. Now let me know guys if this thing is clear. So we have to find out entropy. Okay, so sorry if question is not visible to you. Basically the question here is entropy of data set. Yes, we have to find out entropy of the data set S. Let me see that if the data set is visible to you. Let me know guys if till now anybody have any confusion. Okay, now the question is that find the information gain if data set is split at the feature of elevation. Right, I need to find out information gain if data set is split at the feature elevation. Right, so I got the entropy of this whole data set. I got the entropy of this whole data set as 1. Right, now they are asking that what is the information gain for this particular feature elevation. Right, now how do I find out the information gain? What is the formula for information gain? So see, this elevation thing is gets divided into two parts, steep and slope. Now in this steep elevation, we have this elevation feature, and it gets divided into steep and slope. Right, now if you would see this steep, you have 3 examples of steep, and in this 3 examples you have 2 slow, 1 fast. So you can write down here 2 slow, 1 fast. In this slow section, in this slow, sorry, in steep and flat. Sorry guys, this is steep and flat. So this is flat. Now in this flat value of elevation, I have only 1 fast. So 0 slow, 1 fast. So this is a, so that's how we divide using elevation feature. Now they are asking that what is the information gain. So what is the information gain? First we got the entropy of this whole data set, that is 1. Guys, understand this very carefully. For this whole data set, I get the entropy 1. Now I need to find out entropy of the steep, entropy of the value of this elevation feature, that is steep. Right? For the elevation feature, when it is taking steep value, I have to find out the entropy here. So that means I'll find out entropy of my S data set, S comma steep. I'm finding out entropy of S comma steep. And what would be the entropy? Because 2 slow, 1 fast. So probability would be minus 2 by 3. Oh, sorry. Entropy would be log to the base 2, 2 by 3. Minus 1 by 3, log to the base 2, 1 by 3. Now let me know guys if this thing is clear. Guys, can you use calculator and let me know the answer? Because there is a calculation. Just let me know. Let me see if I have calculation already done. Okay, so on solving you would get this value as 0.918. So that is your entropy for this particular steep value. Now similarly you would find out entropy for this flat value. What would be the value? Entropy of S comma flat. So 0 and 1. So probability would be 0 by 1 log to the base 2, 0 by 1 with minus sign, minus 1 by 1 by 1. 1 by 1 log to the base 2, 1. Right? This would become 0, and log to the base 2 with 1. What would be the value? You can find out log 1 is always 0. Right? Log 1 is always 0. So this value would become 0. So that means you have 0 entropy here. So you can see that you do not have any impurity here. You have 0 impurity here. Obviously, na, when your elevation is flat, you always going fast. You are not going slow. But in the steep section, I'm not able to decide that either I'm going to slow, or I'm going to go slow or fast. But here I know that when it is flat, because of the data set given to me, I know that I'm always going to be flat. Okay, so we got this entropy. Now, what is information gain? Now, you would say that, ma'am, you are asking, like you are telling so many things, but what about information gain? In the question, they have asked about information gain. So, information gain for the feature S comma elevation. S is my data set, elevation is my feature. So, let's find out that S comma elevation. So, guys, remember, what is a formula? So, entropy of my whole data set, minus summation cardinality of SV upon cardinality of S and entropy of SV. SV. SB or S comma V. You can see anything. And what is V? V comma V belongs to values of, or V, what is V here? V belongs to values of elevation, right? This elevation thing, values of elevation. So here we have two values of elevation, steep and flat. So I'm going to use that, right? So what would be the values? Entropy of S I got as 1 minus. Now let's talk about steep, right? I have two values of elevation feature, steep and flat. So if I'll take steep, out of 4 examples, I have 3 steep. So, and in total, I have 4 examples. Cardinality of SV means how many values we have in steep, right? We have 3 values. So 3 by 4 into entropy of SV, I got as 0.918 minus, right? How many values we have in flat? Because V belongs to values of elevation. Now I'll move to flat. I have 1 value out of 4 and entropy I got as 0. Now you can solve it to find out the information gain. Can you tell me guys what would be the information gain here on solving? Tell me guys what would be the value of information gain? So on solving, you would get the value of information gain as 0.311. 0.311 you get as an information gain. Is there any confusion in this? Just let me know guys if there is any question. So now you know how to find out entropy, how to find out information gain. I just like I'm assuming that this thing is clear. Should we move to next question? So the question they have asked, this question they have asked. So I think 0.311, 0.325, if we take 1 to more digit, I'll get option D as correct, right? So 0.325 is correct here, right? So I think there is some calculation you can check by yourself. So 0.325 is the answer. Now the question here says that find the feature on which parent node must be chosen to split the data set. So they are asking that either I'm going to split the data set initially using the feature speed limit, road type and elevation. So for that I need to find out information gain for all 3 features. Information gain for elevation I already got, right? Information gain for S comma elevation I already got, which is what we got 0.311 or 0.325, right? Let's assume 0.325. Can you guys tell me what would be the information gain for road type and speed limit? Let's go back to the table and let's solve it. And I also remember that I got whole entropy of the table is 1, right? Now let's solve it. Road type. Now if I'll talk about road type, for road type I am going to divide it into smooth and uneven. Smooth and uneven. And I am dividing this road type thing. So when I'm talking about smooth, I have 1 slow, 1 fast. Uneven, 1 slow, 1 fast. What would I do? I'll find out entropy of S comma smooth. Entropy of S comma smooth. And guys, you can check by yourself because it is dividing in equal parts. You would, and it is binary classification, so you would get the entropy 1. And also entropy of S comma uneven is also you would get as 1. Guys, you can check by calculation by just using that minus pi log to the base 2 pi. You can use that, right? So once you get the information entropy, you can go for information gain. Information gain for S comma road type. What it would be? Entropy of the whole table, that means 1 minus all the value, all the entropy, right? Or you can say that how many values we have for uneven. Let's talk about one by one. Let's talk about smooth and uneven. I have two values. Your feature road type is taking. So let's talk about smooth. We have two values out of 4, 2 by 4, and we are getting for smooth we are getting entropy as 1. Again for smooth we have two values out of 4 and we are getting entropy as 1. So on solving you would get this value as 0. So that means for this road type you get the information gain 0. For this elevation thing we get the information gain 0.325. Now I need to find out information gain for the speed limit, right? Information gain for speed limit. Now let's talk about this speed limit. If I'll divide it, it gets divided into yes and no. For yes thing we have 2 slow, 0 fast, and here we have 0 slow, 2 fast. So I'll find out the entropy of yes and no. So entropy of s comma yes. So that would become 2 by 2 log to the base 2 2 by 2 minus 0 by 2 log to the base 2 0 by 2. Right? On solving you would get the entropy of s comma s as 0. Why you like you can say that ma'am you have written directly 0, you haven't used the calculator. So guys, whenever there is binary classification and you can see that all of the values coming to the one particular value class, right? In you can see that yes can be categorized as slow. Whenever we have speed limit yes, then it is slow, right? Whenever we have speed limit no, then we have always fast, right? So that's why there is no impurity in this feature. And what does this impurity means? That means we are not able to decide, but here we are able to decide that whenever we have speed limit yes, that means we are going slow. Okay, so yeah, now entropy of s comma no, and similarly in this case you would get entropy as 0. If entropy, both entropies are 0, so information gain, guys I am not solving it completely, you can just solve it by yourself. For speed limit you would get the information gain as 1. You would get this information gain as 1 because it would be 1 minus 2 by 4 into 0 minus 2 by 4 into 0. So that's why it is 1. So for this we are getting information gain 1. Now they asked me to decide that which feature I am going to use for the decision tree for a particular initial node, right? For initial node I'll choose the feature which have maximum information gain, and in this case I am getting in maximum information gain in the case of speed limit. So speed limit is a feature which I'm going to use for my maximum information gain, right? So option A is correct. Now let me know guys if there is anyone has any question in this or any doubt you guys have. I haven't erased the calculation, so if anybody have any doubt, you guys can just ask me. And guys, before moving forward, please like the session so that it can reach to more students. Like we are bringing these questions for you so that you can practice before exams, right? So yeah. Okay, shall we move forward? Option A is correct here. Yeah, this is a question given in GATE DA, right? This question is given in GATE DA exam, that is 2024, last year, because only last year GATE exam happened. The question says that details of 10 international cricket games between two teams, green and blue, are given in table C. Let's see what is table C. This is table C given to you, right? And if you study this table C, you have given match number, you have given pitches S and F, format is ONT, one day, and I think test match and winner, right? This is given to you. So the table consists of matches played on different pitches across formats along with their winners, right? That we have seen. The attribute pitch can take two of the values, spin friendly and pace friendly. So okay, so this is pitches spin friendly or what is it? Pace friendly. F means pace friendly. Okay. The attribute format can take one of two values, one day match or test match. So O is represented as one day and T is represented as test match. Right. Next thing they have said that a cricket organization would like to use the information given in table C to develop a decision tree model to predict the outcome of future games between these two games. Okay, so they just want to draw a decision tree based on the table given to me. Now they are asking to develop such a model, the computed information gain C comma pitch with respect to target S. So now they are asking information gain, they are asking information gain C comma pitch. Okay, guys, just tell me what would be the information gain. Let's just try to solve it by yourself. Let me know what would be the information gain here in chat section, guys. First of all, I need to find out entropy of this whole table, entropy of this whole data set. So let's suppose they have said that C is the data set. C is the data set. Table C. Let's consider that this table named is C. Can you tell me that what would be entropy of this C table? Entropy of C. Guys, just let me know what would be the entropy of C, and guys, just try to solve, just try to do all the calculations by yourself, like using a calculator or anything. Just do not leave that you would solve directly in exam, because sometimes it happens that by mistake you would forgot to take log to the base 2, right? So be clear that you have to apply all those things, you have to do those things, right? So that's why practice questions before that, solve question completely. Entropy of C. So we have two classes here, green and blue. So out of out of 10 example, we have 1, 2, 3, 4. 4 green and 6 blue. So what would be entropy? 4 by 10 log to the base 2 4 by 10 minus 6 by 10 log to the base 2 6 by 10. So that would be entropy. Now you can solve it using calculator. Let me just see if I have the calculation already done. Okay, so on solving, guys, you would get this value as 0.970. You can just put all the values in calculator and let me know if you are getting the same answer. That is your entropy. Now what would be the next thing? I'll find out entropy of C table, but instead of C, I'll find out pitch, right? For pitch, I have S and F. So can I write down C comma S, right? S is what? Pitch. Either you can write down, it's up to you guys. Either you can write down pitch is equals to S, or you can write down S. I have to find out this. So let's see what are S I have. So S, these two are S. This is S. This is S. This is S. So that means 1, 2, 3, 4, 5. I have 5 S. So in this 5 S, how many green I have? 1 and 2 and 3. I have 3 green and I have 2 blue, right? 3 greens and 2 blues. So what would be entropy? 3 by 5 log to the base 2, 3 by 5 minus 2 by 5 log to the base 2, 2 by 5. So this would be my entropy. Now again, you can find out the solution using calculator, right? So I think on solving, you would get the value again as 0.970. 0.970 would be the value. Once you get this value, now you would move to solving entropy of C comma pitch is equals to F. Guys, see, these questions are not difficult to solve, but these are lengthy. So there is so much calculation, and this is gate question. So they can ask these type of questions, and there is no shortcut to solve these questions. You have to do the whole calculation, right? In general, like if you are training a model, you do not have to do the calculation. Computer would do. But because you are giving gate exam, they can ask you to solve these questions, right? Solve these things. So let's solve. Now for F, now let's go back to this F. This is F, these two are F, these two are F. Out of these F, let's see how many green I have. 1. I have only 1 green, right? So that means it would become minus 1 by 5 log to the base to 1 by 5 minus 4 by 5 log to the base to 4 by 5. Because I have one green, then I have four blue, right? So what would be entropy here? 0.721. 0.721 would be the entropy. Final formula for information gain. And information gain I have to find out for C comma pitch. What would be the formula? Formula I already told you, entropy of C. That means 0.970 minus number of examples we have for pitch equals to S. I have 5 examples, right, out of 10 examples, and for pitch equals to S I get the entropy 0.970 minus 5 by 10 again, and entropy is 0.721. On solving you would get this value 0.125. So here information gain you would get as 0.125. Let me know guys if this question is clear. Just let me know guys if there is any confusion at all. Just give me a quick thumbs up in the chat section if this question is clear, because guys this question is based on GATE exam, so everybody should know how to solve this question. Okay, so if this question is clear, let's move to next thing. Can we use decision tree for both regression and classification? Just tell me guys quickly, can we use both? Can we use decision tree for both regression and classification? Yeah, we can use that. What would we do? Let's suppose one of the feature is salary, right? And we have 25,000, 26,000, and we have 75,000, and we have 1 lakh. So we have all these numerical values. So what would we do? We'll take this salary feature and we'll divide it into categories, right? What would be the categories? Let's suppose 10 to 10k to 40k, right? And then I have divided 40k to 80k, and then I have divided 80k to 120k, right? So I can divide into categories so that we can use the decision tree for regression. And if I have to predict the numerical value, so this is if one of the feature is numerical, then I am going to do that. But if I have to predict output value as numerical, then can we do that? Yeah, we can do that. At the end I'll take again average of all the values, right? I'll take average of all those values. So guys, for that we are going to solve, like, I have this question, we have to find out decision tree for this table, right? And this is regression, right? We are going to do that in the next class, but till then you can try this question. Next class we'll have on Wednesday again 5 to 6 p.m, right? Because I'm going to take class on Wednesday, Thursday and Friday, so that's why your next class will be on Wednesday. Be available, and we are going to discuss more questions in that class, right? Till now we have discussed only supervised learning algorithm, then we are going to discuss unsupervised learning, and also we are going to discuss about neural network questions. Okay, so guys, be available, and yeah, just try to solve this question. And I'm writing homework here, just try this. If like, I'm going to solve that in the next class. Abhay is asking, ma'am, suggest me any crash course for GATE DA only, 3 months available. Okay, Abhay, like we are, if I'll talk about machine learning, there are so many, like I have taken lectures, you can go through that, and also you can practice questions here. And also we have our one self-paced course, like if you have time, like we have 3 months available. So if you can go through those 3 months, like you can give most of the time to study, then you can go through that self-paced course, GfG self-paced course that you get on GfG practice page. Okay, so guys, before moving forward, please like the session so that it can reach to more students. And I'm going to continue in the next class, which will be on Wednesday. So that's all from my side. Thank you for joining all. And just let us know after the class in the comment section that what you have felt for the class, like this class should be longer, or what are your feedback? Have you learned anything? If you have learned anything, just give us good feedback as well, right? So you can just let us know that uh, how you are feeling about these lectures in the comment section. Okay, so that's all from my side, guys. Thank you for joining.